All right, let's talk about something we all do. That little tickle in your throat, that sudden bark, the cough. It feels so automatic, so simple, we really don't give it a second thought. But what if I told you that packed inside that simple reflex is an incredible story of human evolution, some pretty wild brain science, and just raw physical power? Today, we are going to unpack the truly surprising science of a simple cough.
Leave it to Jerry Seinfeld to absolutely nail it. He described a cough as being like watching that fat guy catch a cannonball in his stomach in slow motion. And he's not wrong. It's this sudden, kind of violent, and incredibly coordinated event. So let's pull back the curtain on this biological cannonball catch.
So let's kick things off with section 1, a deceptively simple reflex. And to really get how complex this is, we're going to start with a moment that I am sure every single one of us has experienced. Picture this. You take a sip of a cold drink, and a tiny little sliver of ice goes down the wrong pipe. That feeling is instant, right? It's not a tickle that slowly builds up. It's like an immediate physical alarm bell going off in your throat. Your body doesn't even ask for permission. It just acts. And here's the part that might just blow your mind. That ice chip cough is fundamentally different from the cough you get when you have a cold. Turns out we don't just have one cough reflex. We actually have two completely distinct systems, each with its own evolutionary backstory, its own nerve fibers, and its own unique trigger. Which leads us right into our next big idea, section 2, a tale of two coughs. And this is where we get into this really fascinating evolutionary story about how our bodies learn to defend our airways.
Okay, so check this out. It really breaks down perfectly here. On one side, you've got the aspiration cough. This one is mechanosensory. That means it's triggered by physical stuff, like that piece of ice. It travels on these super fast myelinated nerve fibers, which is why the response is so immediate. Bam! Then, on the other side, you've got the sickness cough. This one's chemosensory. It's detecting chemicals, irritants, and pathogens. It uses these slower, unmyelinated C fibers. And this is the pathway that gives us that annoying, nagging urge to cough. So yeah, two totally different systems for two totally different problems.
So you might be asking, why do we need two? Well, let's start with that aspiration cough. As our ancient ancestors were evolving the ability for complex speech, something really kind of weird happened with our anatomy. Our larynx, our voice box, actually dropped lower down in our throats. Now, this was awesome for making all the sounds we use to talk, but it created a huge problem. It put the entrance to our airway right next to the entrance to our stomach. Suddenly, the risk of choking or getting food and drink in our lungs became super high. So this fast, mechanical cough evolved as a direct, life-saving response to that new danger.
Now, the sickness cough, that evolved to deal with a whole different set of threats. Think about it. As early humans started living in bigger groups and using fire, they faced totally new dangers, things like contagious diseases spreading through the community and lung damage from breathing in smoke. So this slower chemical sensing reflex developed to detect those invisible invaders, pathogens, smoke, all kinds of irritants, and get them out. It's basically our built-in first line of defense against things like pneumonia.
So we've got two different triggers, but they both result in the same powerful event. And that brings us to section 3, the anatomy of a 100 mph cough. So how in the world does our body actually pull off this explosive maneuver?
Okay, so whether it's that little sliver of ice or some nasty virus, the signal zips to a part of your brainstem called the medulla oblongata. And from there, your brain becomes this little director, orchestrating a perfectly synchronized 3-act play that involves dozens of muscles, all the way from your throat down to your abs. The whole thing happens in 3 acts. Act 1, the inspiratory phase. You take this deep, sharp breath in. You're basically loading the cannon. Act 2, the compressive phase. Your vocal cords slam shut, sealing your airway tight. Then your chest and stomach muscles contract like crazy, building up this immense pressure inside your lungs. And finally, Act 3, the expulsive phase. The glottis just flies open and all of that pressurized air is released in one single violent blast. And when I say violent, I mean it. How fast is that blast of air? It can be expelled at speeds up to 100 miles per hour. That's literally hurricane force wind being generated inside your own body. It's powerful enough to shear particles and mucus right off the walls of your airways. It's just an absolutely incredible feat of biological engineering. But this guardian reflex, as powerful as it is, well, it isn't invincible. And that brings us to our next section, when the guardian falters. So you might be wondering, how do doctors even measure how good someone's cough is? Well, they use a measurement called peak cough expiratory flow, or PCEF.
It's pretty much exactly what it sounds like. It measures how fast you can move air when you cough. And it turns out there's a critical number. If your PCEF drops below 162 liters per minute, your cough is officially considered ineffective at clearing your airways. And this is a huge deal for people with neuromuscular diseases that weaken the muscles in the chest and abdomen. If those muscles just can't generate the force they need to, gunk and secretions start to build up in the lungs. This creates a really dangerous breeding ground for bacteria, and the risk of pneumonia just skyrockets. But here's the kicker. It's not just diseases that can weaken the cough. It actually seems to be a natural part of getting older. One study set out to directly compare cough sensitivity between a group of healthy young people and a group of healthy older adults, and the results they found were pretty startling. So when you look at the numbers, it's wow. When they were exposed to this mist that's known to trigger a cough, the younger subjects, who were around 27 years old, coughed on average more than 15 times. But the elderly subjects, who were around 83, coughed less than 6 times. That is a massive drop in sensitivity, nearly threefold. What this means is that even in perfectly healthy older adults, the body's alarm system for stuff in the airways is way less responsive, and that puts them at a higher risk for both aspiration and infection. So after going through all this, it's pretty clear that the humble cough is way more than just a minor annoyance at the movies. It is truly our body's unsung protector. It really is a dual-action guardian, isn't it? On one hand, it's our physical bodyguard, protecting us from the unique dangers that came with learning how to speak. And on the other, it's our chemical sensor, defending us against the invisible threats all around us. It's a masterpiece of coordination, and it is absolutely essential for keeping us alive and breathing freely. But there is one final fascinating piece to this whole puzzle that makes the human cough truly unique. See, unlike most other animals, our higher-order brain functions, our cerebral cortex, can get involved. We can consciously hold back a cough when we're in a quiet theater, and we can choose to cough to clear our throat. We actually have a degree of conscious control over this incredibly primal reflex. And that leaves us with this one last, really interesting thought. The line between our conscious mind and our body's ancient automatic defenses is, well, it's pretty blurry, isn't it? We can influence it, sure, but we can't fully command it. It kind of makes you wonder, how much control do we really have over the vital systems that are working to keep us safe every single second of every day?